So this section is where we start talking about solving equations. And so a couple things I wanted to be careful that we know rather than just throwing these words around. What we're talking about when we talk about an equation.
I didn't get one of those sheets.
I'm always forgetting you, and it's like if you're a rattlesnake, you'd bite me because you're just right there, right up front and center, where everyone says you're supposed to sit to not get ignored by the teacher, and there this happens. So I'm sorry. What do we mean by solving an equation? Okay. And another thing, I bet we have some idea here. What do we mean by equivalent equations? That's a word you probably see less of, but we'll see a little bit more of it now. But these words you've seen before, and sometimes they get misused. We think of an equation sometimes as any old mathematical expression, and it's not. You think of solving the problem as getting the answer, and it's not. So let's talk about solving. First of all, what is an equation? What's the key item that an equation has that makes it an equation? What's the key feature you're going to see in every single equation you ever look at?
An equal sign?
An equal sign. Has an equal sign. So something like x squared plus 2x plus 1, is that an equation? No, because there's no equal sign. However, if I change it to x plus 1 squared, is that an equation?
Sure.
Yes. Now you don't necessarily know if this equation's true. It does happen to be true. But it is an equation because it has an equal sign. So now we've got an equation taken care of. Now, the next word that gets used a lot is the word solve. When we solve an equation, when we solve, for example, something like 2x plus 5 equals 13. I'm not sure if that's the exact equation I gave here. I don't remember which one I gave. But when you've got something like that, say solve, whatever that means, 2x plus 5 equals 13. What do you think is going to be the end result? Okay, you know, first of all, you figured out already that x equals 4, so you're probably a long ways in terms of being able to solve these. That's good. But why did you pick x equals 4? So William's saying that x equals 4 is the answer to this thing called solve the equation. What makes x equals 4 an answer?
Subtract 5 from 13, divide by 2, x equals 4.
Okay, so what? So what? What is that? Still doesn't quite get to, and that's the recipe we're going to end up seeing. But what makes x equals 4?
You gotta get x by itself.
Yeah, get x by itself. You have to, or you can plug numbers in and figure out what equals 13.
Oh, we're getting warmer. We're getting warmer. You guys have the process remembered. That's good. What I'm after is, what does this expression mean?
You have to,
And you talked about plugging in numbers, substituting in numbers. So x equals 4 is a solution to this equation because it does what?
because it solves.
Because, oh, that's begging the question. What does solve it mean?
Oh, yeah, find the solution.
Again, find the solution is begging the question. What does 4 do that no other number does?
Makes it true.
It makes it true. X equals 4, this equation is true when x equals 4. That's why x equals 4 is a solution. Now these processes that Ryan and William talked about, and some of you are probably vaguely remembering here, those processes are how we find in a systematic fashion what makes this equation true. But the bottom line is this. We're trying to find a value of x that makes this equation true. That's what the expression solve an equation means. So it's not just get the answer, it's find the value of x that makes this true. When we substitute 4 in for x, you get 2 times 4 equals 8, plus 5 equals 13. You've got a balanced equation and a true statement. So that's what solving an equation means. Now, the way we do this is by producing equivalent equations. Equivalent equations are equations that have the same solution. I am probably running off the screen, so if you can't see the word same out there in internet land, oh, you do see the word same out there in internet land. That's very good. Okay? Equivalent equations are equations that have the same solution. So this is how we think of getting the solution to this problem. We have this equation, 2x plus 5 equals 13. We may or may not know instantly what the solution is to that, but we have a rule that says if you add or subtract the same thing from both sides of the equal sign, it produces an equivalent equation. So in other words, if Mike equals 210 pounds, then Mike minus 5 equals 210 minus 5, or 205. Mike's weight equals 210, that's probably a better way of saying it. Then Mike's weight minus 5 pounds must be equal to 205. So if I subtract the same thing or add the same thing to both sides of the equal sign, I produce an equation that has the same solution as the original. So our logic so far is that 2x equals 8. The equation 2x equals 8 has the same solution as this original equation. Another thing we can do is multiply or divide both sides by something, provided it's not 0. That's another trick we're going to have that produces equivalent equations. So if I divide this entire side of the equal sign by 2 and this entire side of the equal sign by 2, I'm going to get an equation that's equivalent to this, and in turn is equivalent to this. 2x divided by 2, the 2's are going to cancel, that's just going to leave x. 8 divided by 2, that's just going to leave 4. So the equation, x equals 4, is equivalent to this initial equation. But what's its solution? What value of x makes this true? Duh. It's 4, of course. 4 is what makes that equation true. And so we're talking about getting a string of equivalent equations. It's about taking your problem. This is even a bigger idea in algebra than just solving equations. What you're always going to be doing is, within the rules, take the problem you have in front of you, i.e., solve 2x plus 5 equals 13, find the value of x that makes 2x plus 5 equal 13 a true statement, and you are going to pull some legal steps to change the problem, or change how it looks, without really changing how it is. Finding the solution to this is the same as finding the solution to this is the same as finding the solution to this. Why we go through all that? Well, finding the solution to this is obvious.